All right, you guys, I wanted to go over homework 10. Question number 1, marital status can be categorized into never married, married, widowed, or divorced. According to the infoplease.com, the following are the probabilities of those marital status categories for adults in the United States. Data from 2000. Gosh, hopefully we'll be getting some new data with the new census. Data from 2000. That's pretty old. Anyway, to answer this one, you need to remember that your table needs to add up to be 100%. So if you add these 3 numbers up and then subtract it from 1, you get 0.098 or 9.8%. Question 2, it's just kind of the same thing. You are either going to, you could do it 2 different ways. It asks to use the complement rule, which is actually a harder way to do it. The first way would just be to add up these 2 numbers. And that will give you everybody who does not have or who has not graduated from high school. Using the complement rule, you would want to add up all of the numbers that don't match what you're looking for and then subtract it from 1. You should get the same answer for both, doing it either way, the same answer. All right, question 3, what is the probability that a randomly chosen car will have one of the 3 most popular colors? All you have to do is add up the 3 highest percents. Roughly 7% of American males in the US have some sort of color blindness. Suppose that a medical researcher suggests selects one American male at random. So they either A, select a man that is, or a male that is colorblind, or B, they select a male that is not colorblind. So these are disjoint. Okay, if you did your Venn diagram, all of the colorblind people would be in one circle, and all of the not colorblind people would be in the other circle, and there would be no overlapping of your Venn diagram. They would be disjoint. Okay, but this time they want to select, here's the key word here, 2 American males at random. Event A, the first male is colorblind, and event B, the second male is not colorblind. Okay, those are, since there's 2 trials, they are independent, right? It doesn't matter if the first male is colorblind, it has nothing to do with selecting a second male that is not colorblind, although I did put the caveat down here that they would be dependent on each other in some way if it was like a father-son or related males, but I do not think that is what they meant in this particular case. Question 6, according to the most updated data gathered by the American Association of Suicidology, 80% of suicides in the US are committed by men. 2 suicide cases are selected at random. What is the probability that both suicides were committed by a person of the same gender? So I did this 2 different ways. The first way was to figure out the probability that both would be male, would be 80% is the same as 8 over 10. So 8 over 10 times 8 over 10, which gives you 64 over 100 or 64%. And then I found the probability that they would both be female, which was 2 over 10, so 20% times 2 over 10, which would be 4 over 100, which is just 4%. And then I added those 2 together to get 68%. Or something that is I feel like is a really good way to think about it, if you don't have numbers as nice as these, is to make an area model of what's happening. So here on this side of my area model, I have person number 1. On this side of my area model, I have person number 2. And here we have, it is 0.8 or 80% chance that person 2 is going to be male and a 0.2% chance it's going to be female. Same for person 1, 0.8 and 0.2. Then you fill out your area model. So here it's going to be, if they're both male, it's going to be 0.8 times 0.8, which is going to be 0.64, 64% chance. To have person 1 be male and person 2 be female would be 0.16. To have person 1 be female and person 2 be male would be 0.16 here. And then to have them both be female would be 0.2 times 0.2, which is 0.04. And then I just added up. So it's the same kind of numbers here that we did the first time. I added up the 2 boxes where they are the same sex. So they're either going to be both male or both female. And that ends up to be 0.68 or 68%. So just 2 different ways of looking at the same problem. Question 7, survey was taken at a local college campus. The survey asked students if the student was a full-time student or a part-time student, and if he or she worked full-time or part-time. The following chart illustrates the empirical results. Every time I see the word empirical, I think about how I have such a hard time spelling it. Let's switch up highlight colors. Let's do blue. Okay, so question A. If he or she is a full-time student or they work part-time. So if they are a full-time student, the probability out of these sample would be 0.6, okay? And that corresponds here with this 0.6. And this is important, the word or they work part-time. Working part-time, the probability is 0.35, so I need to add those 2 numbers together. But adding these 2 numbers together, I have added in the 0.15 twice. Okay, I've added in that 0.15 twice. So I need to subtract 1 of those 0.15s. Okay, so I add the probabilities, the total probabilities of each one of those events together, but then I have to subtract out 1 of the 0.15 because I've added those people in twice. Okay, so your total, I did this in my head, so please check. Your total should be 80%. Okay. Part B says he or she is a full-time student and works part-time. That's easy. That's just going to be full-time student and works part-time. That's just going to be this box. Okay. So that 0.15. He or she is a part-time student or does not work. So the probability of being a part-time student, the total probability is 0.4. Okay, and the probability that one of these people doesn't work at all is 0.45. So we're going to add those 2 together, but then we are going to, just like we did before, we are going to subtract out the box that we added twice, okay, which was 0.05. If you do this, that should still add up to be, double check my math, I did this in my head, 0.8. Okay, and lastly, he or she is a part-time student and does not work. That's just going to be the box that they are a part-time student and they do not work, which is just that 0.05. Okay, and he or she is a full-time student and does not work. That's just 1 box. It's going to be 0.4. He or she is a part-time student or works full-time. Part-time, the probability, total probability of part-time student is 0.4. Total probability that they work for full-time is 0.2. Then we need to subtract out the box that we added twice, 0.15. So your answer should be 45%. And then question 8's the last question here. You conducted a survey to learn more about the student body of CCD. You asked 500 students whether they have a family and how many credits they are taking. So what is the probability that a student is without a family and taking 12 credits. So again, that word and means we're just going to use that one square, which is without a family and taking 12 credits, 113. Okay, out of the total 500 students. And we can go ahead and do the math. Oh, crud, I always keep clicking on that one. Yes, I'm sure. So 113 divided by 500. Right, 226, 22.6%. And that's just a straight up equal sign since I didn't round. Okay. Next question, what is the probability that a student has a family and taking 12 or more credits? So in this case, the probability that a student, oh no, I think I did this one wrong. It's a good thing I'm going over it. I did the not having a family. So what is the probability that a student has a family and is taking 12 or more credits? So in that case, our denominator is still our sample space, which is 500. But our numerator, if they have a family and they're taking 12 credits, is 68. But it says more, they could also be taking more than that. If they have a family and they're taking 18 credits, that's going to be 24. Okay, so we're going to add those up, 8, 9, 10, 11, 12, carry your 1, 1, 2, 3, 9, 92. Double check my math, 92 divided by 500. Ah, 92 divided by 500, 18.4%. Oops, 18.4%. Okay. Given that the student has, and this is a given one, okay, given that the student has a family, so we know our denominator, our sample space here, is that they have a family. So our denominator needs to be the total number of students that have a family. We are just going to be looking at that row. Okay, so our denominator is 217. The chance of he or she taking 18 credits. So our numerator is 24. So we have 24 out of 17. Oh, that wasn't right. 24 out of 217. Approximately 11.06%. Oops. Approximately 11.06%. And last for this homework, given that the student is taking 12 credits, what is the chance he or she doesn't have a family? So in this case, given that the student is taking 12 credits, our denominator is 181 because that is the total number of students taking 12 credits. What is the chance he or she doesn't have a family is going to be 113. So the probability is 113 divided by 181, or approximately 62.4%.